Hello everybody, and welcome to the first episode of a new video series about this open source tool that I created called Cartograph. And I created it because of a response I had to frustrations with agentic coding in late 2025. So kind of fall, winter of 2025, I tried to make a couple pieces of software that I was happy with, and I ran into issues with the whole workflow, and so I started building Cartograph to address some of them. So in this video, I'm going to talk about some of those issues, and then after that, I will show off the tool a little bit, and then throughout the video series, we'll kind of keep revealing more and more about what the tool does. So what I ran into in the fall that I think still is a problem in agentic engineering or coding and hasn't been solved yet is a issue of models don't always output the same thing, right? They often are going to give you the same prompt and a different answer, which for coding is rather concerning, as when a human codes, we often know, hey, I did this on the previous project, this is I'm gonna write it on the next one, right? There's something I call the debugging tax that gets paid every time you try to implement the same thing into an app based on prompts. And then the solution I tried to have was to take those solutions when you are prompting away and debugging and turning them into portable engineering artifacts. So I'm going to talk a little bit more about what each one of those are here, just quick. So the model variance. One of the things that you will find immediately right away is if you put in the same prompt to these models, you get a different answer every time. And it doesn't change in the 90%, but it's the 10% that's a big deal. So if we talk about, or I asked Opus and GPT 5.5 to explain the uncertainty principle, which is a quantum mechanical idea and mathematical a mathematical solution and a mathematical fallout of the way quantum mechanics works. And we had two good outputs and one what I'd consider bad output. And so specifically what I'm looking at here is the two good outputs mention that position and momentum are one of the properties. And in this response with Opus, it mentioned that it is only position and momentum. And that is not true. There's energy and time. I think there's 2 or 3 other well-known ones, and it falls out from Hermitian operators and whether or not they their commutators commute. So their A and B, or Opus and GPT 5.5, leave room for more than position and momentum being part of the uncertainty principle. Opus 4.8 does not. And if we look at the difference in models here, Opus mentions, looser language about pinning it down, and GPT is a little more strict. And in this case, and this could be some of my system prompt, as they're different for these two configurations of my own. So this is not a measure of model performance, but GPT does a good job of being precise about saying, no, it's measuring, right? It's not pinning down and looser language like that. So that's kind of one, that's what we're dealing with, the model variance. And when you get into code, that plays, a big part, and you change a couple line of code, maybe even one line of code, you can change the entire function of your application. So that is one issue we're trying to fight against. Another one is what I call your debugging tax. So this is what I've found happens when I try to write good pieces of software. I'll give kind of an initial scoping prompt, and then we'll test it. And then we'll go through probably multiple cycles of this refinement prompt of, okay, this broke, this didn't work with the app. What can we change to make it actually work for what we're trying to do? And then we test it, and we kind of keep doing this for a while, and then we finally hit that point where we say, okay, this works the way I intend, and now let's polish it off so that we can actually connect it into our application. Whether that's, this needs to be an API surface, or this needs to be, we need to expose these certain functions, or we need to make these surfaces configurable instead of hard-coded, yada, yada, yada. Whatever that is, this is to me, when I'm in the flow and things are working well, this seems to be the most successful way I can get software put together. But every time you do this, it's a lot of tokens, and it costs more and more tokens. And in the age of Fable 5 and new GPTs and new models getting more and more expensive, the more tokens you spend per problem, the less you can get done. And so this doesn't hurt when you're doing something you haven't done before, but when you've done it on 3 other projects, this starts to hurt bad. So with the issue of model variance and that debugging loop, that debugging tax over and over again, what is the direction I'm trying to take Cartograph to solve these issues and to try to actually maybe make them hurt a little less, is to build what I call what can maybe be referred to as portable engineering artifacts, and in the case of Cartograph, they are called widgets. So kind of the core issue with those first 2 pieces of model variance and the debugging tax is you might spend 2 to 4 hours prompting away a solution to a difficult problem, and maybe even a medium difficult problem, right? And we're not just talking about getting a prototype or a local host up and running. We're talking about going from prompts to a real ready production software. And so you might spend 2 to 4 hours, and even a 50% reduction in this with maybe skills and certain prompts and lessons learned on your side is still a very costly measure to get that exact script you want over and that exact logic you want over. If you copy and paste it over from the project, A, you have to remember where everything is, and B, you're stuck with all those interdependencies your project had before. So what is the Cartograph solution? Is to freeze that solution as an artifact or a widget that you can port around. You can port around different projects, and the agent is in full control of being able to do that. So it's not waiting for you to do it. The agent can go search for these artifacts and go install them very easily. And this only works to me if these artifacts are validated to a floor. If you just store the snippets, all you're getting is garbage out, storing garbage, and garbage in to your projects. So the whole idea of Cartograph is, instead of it just being an easy way to package your code and store it, we're actually going to validate it before we store it to meet a customized per language floor. This is, does it have test coverage if the language allows it? Does it, is it runnable if it's a language that would allow it? Does it have hard-coded values that are going to mess up when you put it into a new project? Does it have API keys in there? Yada, yada, yada. And there's even customization services and what you say is acceptable. All that gets kind of fed through a validation pipeline that we'll feature, maybe not so much in this video, but in the following videos to come, we'll go deeper into what that exactly looks like. And it gets us into our library as a validated floor, so that when we install it, we know there's a bare minimum quality that it's at. And then the other piece that's kind of part of that is, when you put it into your new project, inevitably you might tweak it up and make it a little bit better with your new implementation, and then you can check it back in and get that engineering loop of constantly getting better and better. So it all comes down to these artifacts and these widgets that the agents are going to port around. And now we're going to take a look at how this actually works in your terminal and with your agents. And now we're going to take a look at Cartograph in your command line interface as a real CLI tool. The requirement to run this is Python and Python only. The CLI was written in Python. So to pull it down, you will run pip3 install cartograph-CLI. And we're going to run that now and pull it down. And one thing you'll notice is that it is 0 dependency to start. So when you pull in your CLI tool itself to get access to your Cartograph on path, you're only getting the code written in the CLI, and this is to protect it against supply chain attacks at its base, and to really make sure that the CLI itself is clean and simple and not over-engineered for our case. And so with that installation, we now have access to Cartograph. And one of the first things you want to do is run Cartograph Doctor. And this is going to pull up a couple things. One of them is the directory for your library, so you can see where your widgets are being stored on your machine. And then the other list is what will be the ever-growing list of languages. So you can pull in the CLI, and it really can't do much to start because you don't have the dependencies you need per language. And this doctor will tell you what you need to get your languages going. Now, do not go and start installing everything you need for every single language. The tool is built to be modular. So if let's say you're a developer that wants to combine NIM, OpenSCAD, and System Verilog together in your project, just install those engines. You don't need to go around and make sure you have every single language. So the tool stays modular, it stays clean, and you only use what you need. So that is the surface of languages. One thing that you notice is we didn't have access to Python yet, and this is the language I want to show off today, since it's the language I've installed on this machine. So we're going to run pip3 install pytest and coverage. And now we're green. So Python is ready to go, and we can actually start using the tool. So now, I guess I'll mention this before I start diving into some more of the commands. If you are someone that just wants to go right into the MCP and forget the CLI, you can run this command to get your MCP. It will pull in the CLI as a dependency, so you can just run that command, and it'll give you everything you need to start running with it. And then your normal MCP add command that you'll run with whatever harness you're using, it'll just be cartograph-mcp is the command that will start up your server with no sub-arguments. So that's the MCP surface, and I'll go over that in more detail in a later episode, but that's just to let you know that there is one, and you can hook into it today. But we're going to start with the CLI to kind of show the inner workings. And now we're going to step into the shoes of the agent here for a little bit. So these are commands that your agent will run, not you, but we want to show off kind of what's going on I want to show off what's going on under the hood before we hand this on over to our agent. So let's say that we want to build some PySide 6 application in Python. Well, one of the primitives we need is some sort of window management for what we're doing. And so I might send a prompt to Claude or somebody or one of the agents and say, we want to build a PySide 6 application. It might extract that this is what it needs to search for to get started. And so we can run Cartograph search on that query. And what you'll notice right away is we get results, 2 separate lists of results. So we get a local one, which will be empty because we just installed it onto our machine today. And we get a cloud registry one. And this is a public free registry that I have running right now that you have the ability to opt into to publish widgets to as open source software under an MIT license. And that's for kind of creating a network effect so that when you install this tool, you can use stuff right away, and hopefully enough people, start contributing where we have a global connected network of a bunch of different implementations of software that agents can pull from at any time. But because we had enough of a, general search, we got up to 10 counts in the registry. That is limited to 10. It will never go more than 10, so that we don't kill the context to your agent. And it's pulling in a bunch of the PySide 6 stuff in our search. And one of the things you'll notice as well is because we use window, we also are getting some NIM widgets that are in that registry. So even though we don't have NIM installed, the engine's not working, we still get the search result. If you would like that feature off, you can run Cartograph config. And this is kind of your configuration surface of some base settings. And we can flip this show unavailable to false. So Cartograph config show unavailable false. It can help if I spell it right. There we go. And so that sets it to false. Now if we run that search command again, you will notice that we're down to 8 widgets, and it's because those NIM widgets no longer show up. So if you only want your search to return the languages you have installed, that is a surface that you can configure to keep it that way. It's default on so that you can see that there's stuff actually living out there, and you can maybe get some inspiration for ideas, but you can shut it off. So search is the discovery pattern for your agent, and the cloud registry and your local registry will sort it by relevance. And so our most relevant one here is this front end widget. And I think I want it. So we are going to run the install command on it. And that is simply going to be Cartograph install. And then that ID that shows up here. And when we run it now, you'll see that we get a success, and we pulled in the widget itself. So we got there's a warning message in here that anything that's in the cloud was validated on a local machine and then sent up. So if someone for some reason wanted to have the validation pipeline be spoofed and send widgets up, that can get into the public registry. So there's just a warning to the agent that it would be in your interest to read it before you do it. And I guess that's something I'll mention too, and your agents will do this a lot, is instead of having to download to look at it, you can also run this inspect command to get a little bit more information on it. And if we do, get the help here, if we do -- source, the agent will have access to the actual raw code as well. So you do not need to install and put this code on your machine to see what the widget is going to actually be. So that's kind of your discovery surface for your agent, and there's more going on there that it can do, but that's the base gist of it. And so now we have it installed. And one thing you'll notice right away is when we install it, every widget lives in the CG directory, and that gets auto-populated and created based on your current working directory. The install command can target a directory as well if you want to put it in a certain spot. But the CG directory is for housekeeping. It's so that Cartograph itself doesn't have to go searching in 1,000 different directories to manage everything. It can know, I'm working in my current directory, I'm going to the CG directory. That's that. So we're going to take a look now at the actual widget that got installed. So let me pull up my VS Code here. And we're going to do a quick flyby of the actual internals of a widget. So when you install, there is a metadata JSON file that is included with your widget. And this is a lot of it, and most of it's for search discoverability and for, it's entirely for search discoverability. It's so that you can know exactly what's in this widget without having to read the source code. We can see the dependencies that the widget depends on. So, if you wanted to go for something, if you didn't want to use the dependency, you need a dependency-free widget, etc. So this is your metadata. And then you have 3, in most languages, almost all of them, I'd say, I think, you have your 3 different pieces included with your widget. You've got your source code, which this is the meat and the potatoes, the logic of what you're actually doing. You have tests, And based on the language, some languages require, if it can do test coverage, 80% test coverage. And it, this is to help so that if you want it, if you're editing the source, you can keep the regression tests in, and you can make sure that the widget still does what you intend. So this is for, kind of proving that your widget still works. And then it also includes an example of how to utilize it. Since the source, this is so that the source code itself stays as highly modular and reusable as much as possible across projects. And there's a different validation bar between source code and examples. Examples, you can get away a little bit more with calling in hard-coded variables and other things, so that you know for a fact that this is how this is a idea of how you should implement it into your app based on the logic you import from your source code. And then there's a sidecar here for letting you know where this came from. That's important. This is an important piece that lets Cartograph know that this was actually installed from the public registry, which gets important when you want to start checking in changes to the public registry rather than your local. And then, so this is what a widget looks like. It's a neat, tidy package with everything you need to, it turns into almost a micro library that's executable. And if we look here, I'm going to kind of bring this up before we switch over to actually running Claude to implement this. We can, the core of the tool is to be able to validate this widget to get it before you put it into the library, right? So we have these validation and check-in commands. Checking in is for getting it into the actual library, and validate has to run and finish before you can actually check it into the library. So if we look here at our widget here, let's say I had made a change, which obviously I haven't, but that's okay. I can run this command, and it will now run the validation pipeline through our widget itself. And this is stressing, that it looks a certain way, and that it, and I'll go more into what the actual validation engine is at some point here, but what this validate command is doing is it's making sure that the widget passes the standards Cartograph sets, and that, the metadata has everything filled in that needs to be, and it's ready for check-in. You'll notice it was slow. You may have saw that a virtual environment got popped up here. That is because in Python, if the dependencies themselves are not installed, it will pop up a quick temporary virtual environment to install the dependencies to run the validation and then kick it out. If you had it installed, it would just use your installed one. So that's why the validation took a little bit longer this time around. But you'll see we got this widget is valid, and what it'll carry with it is your validation stamp. And this is so that you can now be confident. This is so that when you check it in now, it can read this validation stamp and know that it's good to go. If you just run check-in without validate, it will also do the same validation pipeline, and it'll put this validation stamp on there. So that is a widget, and that is the agent side of what is happening behind the closed doors of Claude, I'd say. And now for this next section, we're actually going to boot up Claude and let Claude work with the widget to kind of show how it interacts with the tool. One quick thing I'm going to do before we do that is there is a Cartograph setup command. And this is so that you don't have to do a bunch of work to get your agent to understand how to use Cartograph. If you don't want to install the MCP, you can instead do, and even when you install the MCP, I found that this setup command is quite helpful for it. We can run Cartograph setup, and we can target our agent, which we will be using Claude. And then when we run this in this directory, it will append this to your Claude MD file. So it won't rewrite your Claude MD file. That stays protected and safe. But now it'll give it an explanation of all the command surfaces, what each config mean, the configuration surfaces. I guess this is mostly your, -- help. Here's the config keys. Just giving Claude general knowledge of this Cartograph tool you have installed, and a couple quick tips and things for housekeeping. The other thing you might notice is that we can do a -- workflow. Oh, sorry, move that around. We can do a -- workflow on top of it. And this will add, if we come down here, this will add some workflow steps to the bottom of, this is kind of, I did some testing of it, and this is how I found that it ended up working pretty well when Claude followed these. And this is something that you have the ability to create custom workflows. So this would just be an MD file, right? And you can write your own workflow and use the -- workflow, and it'll attach your workflow that you have for Cartograph, or you can use the default built-in one here. And this will now let us, when we boot up Claude here in a second, it'll let us actually work. So we're going to go there right now. Okay, so welcome everybody to the actual Claude Code portion of using this CLI tool. So we are going to build with what we have created in our widgets, and we're going to show off the wiring up side of a widget, and also we're going to have Claude create a widget for us. So install Python 6 and get a setup. Setup for our widget. So we're going to take a look at actually having Claude work with everything, and it's going to go work and discover everything. And this is not a video about Claude Code. We know how Claude Code works, but we're going to let it hook things up here, and we're going to push through. It's got to put everything together and set up our project environment quick. But what we're going to see is Claude understands intuitively how to actually hook up a widget, because it's no different than importing a library, or maybe your code file you have with all your logic that you push around, and now it just knows, okay, let's wire that into our application. And it's taken its time to actually get it going here, but okay, so it's actually writing the demo now, and we'll accept all edits quick so that goes through faster. So we'll give it kind of a second to run through that. But the whole idea now, as kind of mentioned earlier in the video, is this logic that controls our frameless windows is now set in stone. And so for something like this, maybe it's not so important. And here we are. So we have a nice frameless window here to start, and we can see that we have a By-Side 6 application, and I kind of tossed some things in here. This doesn't really show off that widget too well, but it is now put together. Now I'm going to explain quick, where to go, a concept that we understand, that Cartograph understands as well, or the instructions help make it understand. This type of what I call a configuration surface, and just your app logic and your project logic, is what is referred to as glue code. So your widgets will be in your CG directory with your logic in your source code. And then your glue code is going to compose those widgets into your project, right? So this way we can actually get your project specific changes in there and make it so that you can build the application you want by using the building blocks Cartograph is helping provide. Get a grid layout. So I want to kind of get a grid layout in that to maybe, show off some more organizational skip. And this is maybe something now that Claude, we're still fighting Claude, or I still have to fight Claude a little bit to use Cartograph all the time. I could be more authoritative on my Claude MD file to say you have to use it, because that's a case where maybe you'd want Claude to search. You have a request for something. Let's actually, use a real organizational widget. So I want to show off Claude actually searching for a widget. So here we go. It can use your search command. It, put in a couple more things to narrow it down. And it's narrowed down the search, as we were kind of wide, and now it's doing what it needs to do to search for stuff. And it looks like we may not have what we need in the library. So it's kind of, it does a good job of searching far and wide. And you can see it also does a good job of making sure that things don't get too exploded and big. So this is a good, good on Claude to understand how to take even what's been condensed and to make it even smaller. So, and here we go. Now it understands already the workflow. I was going to ask it to create, and now Claude is already suggesting. So we are asking for a certain type of thing, and it goes, this is textbook reusable, right? And now it's asking, do we actually want to create a new one? And yes, I do, because I want to show off the actual creation pipeline. So we'll get all these commands. You'll see that there's the create command, gives you the option to have a name. You can attach a domain, which is part of that slug in there, and then a language we're specifying. And it didn't like the name for some reason, so it said, let me use the rename, which, yes, it did work. Okay, good. And now it's going to start writing code for this widget. So you can imagine, as Claude kind of works here, I imagine there's two ways to work with widgets. One is this way, which is to simply just let your agent run away with writing everything. It'll, run the, I guess this would be a good chance to actually show before it rewrites everything. The, so this is when you create a new widget, these are your placeholders. At the beginning, you have a bunch of to-dos in there and some initial scaffolding, and now Claude can work with it. There's to-dos in here, and these to-dos are important because if this to-do with the bracket is in your widget, it will fail, or if to-do in general, actually, I think, is in your widget, it will fail validation. So these all need to be filled in and done. And a lot of times I've noticed Claude isn't as bad as it, but some of the other harnesses tend to struggle to understand that concept, and so they will often not fit all the to-dos, and validation catches that. So that's part of the cleaning up to make sure, some of those to-dos are for, hey, you actually need to write a test. Some of them are for, you actually have to fill in tags so that the search algorithm can find your widget, that type of thing. so Claude is working. So this is kind of one way I imagine it. Another way is letting you take the time to write the source code yourself. It allows for that, right? Because if you think about what a widget is, if you put investment into making it a really good self-contained piece of software, that becomes instantly valuable to your agent later on, right? This is now not just about, hey, can we, make it, and you can see Claude is running the validation, and it has it caught some errors that would make this widget not actually work properly. One of them is just the fact that it tried to run I see. No. Oh, this could be, I wonder what's going on here. This might be, well, let Claude kind of work on it, but that was, it's a little odd, but either which way, one of the things that, Claude is doing is we're giving, the tool is going to give it error messages to allow it to debug, and look, it recovered, right? So that's a big deal that's a, some of the work that's been done is so that when things happen, Claude is still able to recover because it understands what went wrong in the validation pipeline. So the key is not just to validate, but to give Claude the ability to recover and to actually make it through the validation pipeline, right? So we can see it's in action. Now it's wiring it up into our application so that we can actually use it. And we're going to see it pop up, and this will be the full life cycle of your widgets. And the question now obviously becomes, well, okay, we could have done all this before we had the widgets. And the answer to that is yes, this is true. And these are very simple implementations that I think a lot of us would trust Claude to do. But you can imagine as we scale up to more difficult, interesting engineering artifacts, it becomes more important to freeze this type of logic. So we already had the frame. The windowless frame to put things in on a pi side 6 side, and now we're going to have a grid. And there it is. So now we have an actual layout grid that is in our pi side 6 application. Come back, please. Wanted to see, because it made a mention that it was, no. It made a mention it was responsive, but I guess the window itself, well, that's not quite what I was looking for. But now there's a bit of responsiveness in there, it looks like. But this is kind of now this is maybe what I'm starting to kind of talk about is, okay, we have this base to work from, part of these widgets. It looks like, our windowless frame here is, oh, there we go. There's our responsive. So we can't pull off on the right, but we can pull off on the left, which is an odd, oh, that was weird. I must have just been pulling it wrong. But you see we have a responsive grid now in pi side 6, all ran by widgets. And so, yeah, I think at a small scale, this is, shows off that we can still do software development in this manner. And as things get more interesting and more testy and more difficult to implement, I think this tool becomes more valuable. So there's kind of proof it works and some of the, maybe hiccups it runs through, but also the successes it has. And throughout the course of these videos now, we're going to show off more and more of this tool. There's a lot more it can do. This is just the core workflow. And yeah, so I hope you enjoyed this video. I hope you are seeing the possible value. If you want to try it out, I showed you the install commands there earlier in this video. The description will have links to It should have a link to the GitHub. It will have a link to the PYPI. It will have also a link to a notebook LLM that has a lot of documentation. So if you want to, instead of waiting for all these videos to come out, you can take a look at the notebook LLM and chat with it and see what all is possible inside this tool. And yeah, so in the next video, I'm not sure exactly what I'll dive into, but we'll dive into a part of it. And I hope you take the time to try this out and see if it works for you. And when you run into issues, please leave issues on the GitHub issues. Like I mentioned before, it is open source. And I guess I can kind of pull over the actual repo here. It is open source, and it has discussion attached to it, and you can raise issues as they pop up. And yeah, so I'm hoping this is usable by people, and people find it to be beneficial for their agentic coding, especially when they need more precise applications. And I hope it kind of lets you spend less tokens and less money redoing the same things, and you can now be confident that your agentic solutions are validated, and you can reuse similar logic across projects. So thanks everyone for watching this initial intro video, and I will talk to you in the next episode.